Welcome to the next video of GPR. In this video, we will be discussing about how deep can a GPR see. Whenever people see a ground penetrating radar system, they usually ask how deep can it see or how deep can it measure. They ask can it go for 1 meter or can it go for 5 meters or 10 meters or even deep. So we will discuss about that one. The answer is it's not simple because there is no fixed depth for the ground penetrating radar. The depth usually depends on several factors. And today we are going to understand exactly what controls the ground penetrating radar depth. So let's start with an example here. Imagine you're standing on uh, like uh, in the night with a flashlight. If the air is completely clear, the light will travel a longer distance. But if you have any fog or any kind of cloud, this light won't travel much. So here the flashlight is not changed, but only thing is the medium or the environment is changing. The same way, when you are using a GPR, it sends the electromagnetic radiation and it is coming back again. So depending on the type of the soil, this changes. Example here I am giving you dry sand, gravel, wet soil, and clay. Just for the example. In some dry sand environments, GPR may reach a greater depth, like 10 meters. If you take clay, it goes very less. That is because clay contains moistures and also some dissolved ions. These materials absorb the electromagnetic energy. So as a result, the signal becomes weaker very quickly in the clay, and in the dry sand, it not absorbing anything. So the radiation will be high for a longer depth, like 10 meters, for example. So, in some clay rich environments, the penetration will be limited to only 1 or 2 meters. So, the same GPR, when you are using it in the dry sand, it gives you a different result. And when you are using in the clay, it gives you a different result. This is one of the first factor. And the second factor we are going to discuss about is the water. Water is one of the biggest controls on the GPR performance. So, example, there is a land and it rained. So, the water content is increasing. Then what will happen? The signal slows down and it will also lose the energy. That means this has a lesser penetration depth. This is why when we are conducting any kind of survey, we should preferably go in a dry season, which will be very favorable for the GPR survey. Or if you go for the rainy season or when the environment is wet, it will create a problem. This is the second thing. And third thing is the frequency. So this is one of the most important concept in a GPR because higher frequency antennas are provided for better detailing, but they cannot penetrate very deep. And when you have lower frequency, the antennas provided deeper penetration, but the image becomes less detailed. So think just like you're having a camera. You can zoom in and zoom out. When you zoom out, you see a larger area. And when you zoom in, you see more details. So both getting at the same time is difficult. So let us take one practical example, then you'll understand clearly what I'm trying to say. Suppose we have 100 megahertz antenna. This antenna may reach several meters underground under the favorable conditions. Now consider a 500 megahertz antenna. It provides excellent details near the surface, but the penetration depth is usually much smaller. So there is always a trade-off, the more depth or more detail. Here is a very common mistake. Many beginners think that deeper penetration automatically means a better survey. This is not true. Imagine if you are looking for an underground pipe at 1 meter depth. You don't need 10 meters of penetration. You need a clear image of that pipe. In this situation, resolution is more important than the depth. That is why professional surveyors first ask what is the target. Only then they will choose the antenna frequency. Now, let us summarize what we have discussed. How deep a GPR can see, that depends on the soil type, moisture content, electrical conductivity, and the antenna frequency. There is no single penetration depth that applies everywhere. The same system may see 10 meters in one location and only 1 meter in another location. So, understanding this is one of the first step towards becoming a good GPR interpreter. So, in the next video, we are going to answer another very important question. Why do some underground objects produce strong reflection while other objects become almost invisible? And that will introduce us to one of the most important concepts in the ground penetrating radar reflection. So, see you in the next video. Please do subscribe and watch the other videos related to the GPR. Thank you.